Hey Kevin, thanks for making it.
Oh, hey,
Yeah, hey,
Solomon.
yeah,
Hey,
everyone,
Nathan.
everyone should start to trickle in around 6:10.
Sure. Yep.
Yeah.
No worries.
Yeah, I'll start by just introducing the class and just talking a bit about MetaMask and Remix, and then I should have enabled screen sharing for you already.
Okay. Yep.
And then just take it away from there.
Perfect. Yeah, sounds great.
Cool.
Can you guys see and hear me okay?
Yeah. I can
Cool.
hear you clearly.
Yeah, great. How's things in California? I assume that's where you guys are.
Yeah,
Or
I'm
most
from
of you?
the South Bay, so
Oh,
it's
nice.
pretty nice. I guess it's somewhat cold right now, but not too bad. How
Yep.
about yourself?
I'm in Austin, Texas.
Oh, nice.
And normally, I mean, it's Texas, so I guess it's pretty warm, but funnily enough, right now, there's like crazy, and not tonight or tonight, but I think over the weekend, like crazy weather warnings. It could drop, at least in Celsius, which is my default is, I think at -14 it could get to. So in Fahrenheit,
Wow.
I'm not sure what that is, but it's super low, especially for
Yeah.
Austin. So yeah, but generally it's really mild here in the winter, and then obviously summer is pretty warm.
Yeah, I heard in Austin, the like weather got really cold really late, but when it got cold, it got like super cold.
Yeah, it kind of does. The weather here is kind of weird because it can fluctuate a lot in a day. Like it can go from, I mean, in the summer, less common to be less likely to do that, but kind of for spring or winter, of course, it can be like pretty pleasant, and then later in the day, it's like freezing, or vice versa. Yeah.
Yeah, that at least in California, it's not as bad, but I definitely get the dilemma where you have to like bundle up and then take take off your layers and then put them back on.
Yeah.
It's really frustrating. Yeah.
Yeah.
How's the whole COVID situation over there? I assume it's, or at least they're not as stringent in California, but California has been like really bad.
Yeah, Texas has been pretty bad too, to be honest. Yeah, my wife actually had the vaccine. It's been a tough day because my wife had, which is good, had the second vaccine, dose of the vaccine yesterday night, but she's been pretty under the weather today, and we have 2 young kids, so I've been like having to kind of juggle all that stuff. But that's the I guess to the bigger picture. Like the vaccine seems to be kind of making its way out here, but which is, and I guess nationwide as well. But yeah, I mean, in terms of sort of how bad things got, and they're still pretty bad, I would say. Like, yeah, pretty rough. I mean, I think here in California have been the 2 rough spots, I think, right?
Yeah, it's interesting. I guess it's kind of the new norm now. Well, hopefully with the vaccine, everything kind of goes back to normal.
Yeah. Light at the end of the tunnel, hopefully, right?
Yeah, exactly.
Hey, Kevin.
Oh, hey, Simon. Good to see you, man.
Yeah, I'm super glad that you come to this lecture.
Yeah, well, thank you for having
yeah.
me. Yeah, thanks for the invite.
Yeah, for sure. I think Solomon and Nathan are really excited to have you. I'm trying to drop by and say hi and thank you for. Actually, so you proposed a project idea, like on the call last year, and Solomon and Nathan and Ayush actually implemented it. So they made a project for the course for students to complete. Yeah, they can tell you more
nice.
about it.
Oh, sweet. Yeah, I'd love to hear.
Very helpful for our course.
Yeah, that's awesome. Yeah, great. Well, you guys are all, I mean, as you're all, of course, intimately aware, the space is kind of on fire right now, right? I mean, it's after a kind of wintry type like period, which is fine in the bigger picture. But yeah, I mean, things are crazy.
Yeah, it's at least like I love to trade stocks, but I guess like I don't know if you've seen at least Elon Musk pumping Dogecoin.
I know. So ridiculous. And like in a kind of good way, I guess, but in a kind of crazy way. Yeah, it's wild.
Yeah,
it's great though. Like a lot of companies are like storing their cash flow in Bitcoin. I know Tesla's the latest to do it. MasterCard just announced that they're going to accept payments in crypto, so that's pretty cool too. So I guess like the adoption is coming slow and steady.
It feels that way, right? Yeah, I mean, lots of kind of big announcements, and just kind of, as you said already, like corporate America in a sense, who historically have been, at best kind of hands off, or at worst kind of pretty anti it. Are really, it feels like the pendulum swung a little bit, right? To wherein it's everyone's sort of testing the water or more, right? Kind of going all in to some degree with Tesla at least.
Yeah, it's definitely cool. Avinash, to answer your question, we can discuss. I can probably discuss over question 4 once if there's time. I know that a lot of people were asking about that, but if not, just
what question was it? Is that for the iPhone notebook?
Yeah, it was the it's basically like the proof of work function, like to actually implement like a proof of work logic. So a lot of students were kind of tripped up on that. So yeah.
Oh, that's good to know. I wrote that homework like that midnight sometime last year. I don't quite know what's going on. Yeah, there's a bug in the homework. If anyone can find it, that's very nice of you if you can spot it. Yeah. Yeah. Anyway, yeah. So Nathan told me we hide the answer from last year so people can do it again, which is nice. Cool. All right, I'll hand off to you guys. I'm gonna head out.
All right, thanks, Simon.
Here today, so.
Good to see you, Simon. Yeah, chat soon, man.
So.
All right, we'll just wait a couple of minutes here. I don't know if you're familiar with Berkeley time, Kevin, but it's kind of a standard for all Berkeley classes and like gatherings for that matter to start 10 minutes after their like said time.
Okay.
Yeah, I guess it's kind of like a way for students to have a little buffer between if they have classes and stuff.
Yeah, that makes sense. Yeah.
And so I guess like with Zoom, it doesn't really make sense to show up earlier than 6:10 because you'll just sit there staring at the screen.
So it's become kind of embedded now, right? People to come in at 10 past the hour.
All right.
So this is just the this second week into
week 2
into the course. Nice.
Yeah.
How long?
I believe it's 8 or 10 weeks. I'm not entirely sure.
Oh, okay. Yeah.
Yeah, it's the full semester basically, but we started a couple weeks late.
Gotcha.
All right, it is 10 past, so let's get started here. Yes, congrats to all the Bitcoin owners. It is almost at 50K. Yeah, crypto has been absolutely mooning, so definitely good to see the FOMO kind of kicking in, and everyone and their mother trying to get in on the hype. So all right, so welcome to week 2 of the Blockchain Developers Decal. Glad to see you all here live. Just some administrative announcements before we kind of begin. Homework 1, we extended the due date to tomorrow at 11:59 p.m. I know that people were having some issues with that, so please continue to make some private piazza posts if you're struggling, and the goal is to definitely have everyone complete it and make sure to submit to the Google form by tomorrow at 11:59 p.m. And then homework 2 has been released. This homework is simply deploying a smart contract, and we'll be talking about the developer tools to do so during this lecture. It should be a fairly light homework relative to last week, so that's definitely good. We don't want to be overwhelming you guys. And then in terms of the reimbursement forms for this class, we will process those. So sorry that we got those enrollment codes out late. I sent them to the club and they should be handling those. Are we going to be covering proof of stake? I believe for the sake of this lecture, we will not be covering it, but the blockchain fundamentals decal covers that in depth, and I believe we might be covering it in a future lecture. So without further ado, I'm super excited to be talking to you about the different developer tools that we use for blockchain and smart contract development. We're privileged to have a guest speaker, Kevin, who is the head of training and ecosystem engineering for the blockchain, the TRUFFLE blockchain group, which is basically they create and develop the de facto standard of blockchain development tools. So it's a really great opportunity for us to learn. So just kind of diving in here, can you guys see my screen?
Okay. Yep.
Okay, cool. So this is kind of our roadmap. We're gonna talk about an overview of the development tools. I'm mainly gonna be covering MetaMask and Remix, and then Kevin is gonna be taking the helm on TRUFFLE and GANACHE. That's his bread and butter, of course. And then Nathan will be rounding it out with Solidity basics. So let's get started. So let's just talk about development tools for a second. It's really important whenever you're developing anything, whether that be making your own app or creating a website. It's really important to be leveraging these set of development tools, which make your life easier and help you create more robust code and streamline your development process. So in particular, when it comes to blockchain, there are several tools that we have at our disposal for Ethereum and smart contract development. The 4 listed here are MetaMask, Remix, TRUFFLE, and GANACHE. So just kind of diving into our first tool, which is MetaMask. MetaMask is basically it's an extension that you can download for your Chrome browser. And it basically serves as the bridge between the browser and the Ethereum network, allowing you to deploy dApps. dApps are basically like decentralized applications. And MetaMask allows you to deploy these dApps without actually running your own Ethereum node, which is really important because running your own Ethereum node is it takes time and energy. So being able to have that abstraction and being able to outsource it to MetaMask, which uses the Infura node, allows us to actually deploy these our smart contracts and operate in the Ethereum ecosystem. Yeah, so just an overview. Like I said, MetaMask is a Chrome extension. It allows you to also maintain your identity on the Ethereum blockchain with the creation and management of identities and accounts. And you can, MetaMask can also serve as your identity. You can send, receive, execute any sort of transactions on the Ethereum network. The next development tool we're going to be talking about is Remix. Remix, I'm sure you guys have dealt with IDEs before. It's basically kind of an environment, like a sandbox for you to streamline your development with text editor, console, debug console, as well as any testing frameworks and additional tools, all kind of packaged into one application. So with Remix, Remix is actually a web-based IDE. So if you type, I believe it's remix.ethereum, or you just search up Remix on Google, you should be able to pull it up. And this is kind of how your IDE will look. You have your standard standard text editor at the top right, and then you have your debug console at the bottom, and then on your left you have your file directory and ability to navigate, as well as you can compile your smart contract. You can deploy it onto your test network or to the Ethereum network, and so on and so forth. So I'm not going to go too deep into that, mainly because you will be exploring this for your homework. And if we have time at the end of this, we'll be showing you a demo. But it's pretty straightforward and really cool. It's also nice that Remix is on your browser, so you don't have to download any application. And maybe it may not be the most polished IDE, but it's the best we have at the moment for Ethereum development. Cool. So without much further ado, I'm gonna pass the stage over to Kevin, and he's gonna talk to us about Truffle and Ganache.
Cool. Yeah. Thanks, Solomon. Let me go ahead and share my screen. Alrighty. Can you guys see that? Let me just get the right thing.
Yeah.
Yep. Awesome. Is it blocked? Can you see the entire? Let me full screen it. Sometimes Zoom does a kind of overlay of the thumbnails of the people. Can you see the entire thing? I mean, say the question differently. Can you see my entire screen? No blocks.
Yeah,
all I can see is Google presentation. Yeah.
Cool. Awesome. Yeah. Well, thanks, Solomon, and yeah, thanks for having me, guys. Yeah, as mentioned, I'll be diving into TRUFFLE specifically and Ganache, and I'll touch on a couple of other tools as well. It's a little confusing because the kind of umbrella name for the suite of tools that we have is called the TRUFFLE suite, and one of those tools within the suite is called TRUFFLE. So it's a little bit confusing because we have others, as was mentioned, Ganache and then more. So yeah, the goal with this section is to kind of dive into that, give you a good flavor. Specifically, what I was going to cover in terms of an overview is TRUFFLE itself. As we'll see, it's a command line tool. Tons of features. I'll also mention boxes, something called TRUFFLE boxes, as a kind of complement to the CLI. And they're kind of pre-packaged projects that you can experiment with and play around with, and really, really good for, particularly if you're getting started from a learning standpoint, and or as a boilerplate for a project you might be working on. We have a kind of ton of them, which is pretty neat. And then I'll talk about Ganache, as mentioned. And we have two flavors of Ganache, a CLI-based version and then a GUI-based version as well. The latter being particularly good, I think, if you're just starting out, just because it's a lot more visual and kind of when you're in that stage, perhaps where you don't know what you don't know. Ganache UI we kind of hold your hand a little bit more. You've got nice kind of tabs along the top, a bit more like Remix, as Solomon was mentioning in that sense. I also wanted to show one of our newest tools, which is something called TRUFFLE Teams, which is similar to Remix in the sense it's browser-based, but it does other things. As a complement to Remix. It's not an IDE in the sense you wouldn't develop specifically within Teams. It's a little bit more on the kind of DevOps side and debug side as well. So those bits I mentioned, I'll talk through. Time permitting, I've got like a hands-on. That wording's a little bit off there. Hands-on with a TRUFFLE NFT. It's using an 1155, which if you don't know what that is, don't worry. That's just a kind of standard, a sort of newer standard for something called a ERC 721, which again you might have heard of. So I'll show that in context. Actually, in Teams. Brief side note: today I learned, was it today or yesterday? Because I'm on a new laptop here, which is one of the new MacBook M1s, and I don't think TRUFFLE CLI actually works on Apple Silicon. I need to confirm it, but I did try and install it last night because I have a kind of a day-to-day desktop, and this is more of a kind of roaming machine, yeah, I just kind of discovered that. So FYI, but we'll get to that later. And then I'll close out this section with just kind of a few next steps on how, if you want to go further with TRUFFLE, and then Q&A. And on that point about questions, feel free to throw them into the chat as we go through, and I'll try and keep an eye. Let me just see how I can get those up there. Just see. point about doesn't run with Rosetta Stone 2. Good question. Yeah, I don't know. I mean, it definitely theoretically running like a Docker container, which is one option. It was something we'll solve resolve anyway. It's just yeah, just kind of a side note. Cool. All right. So kind of jumping in to Truffle Suite at the kind of 10,000 feet view, really as a kind of mantra. It's all about getting, helping a developer who has an idea for a decentralized application or a DApp, taking them from that idea to the kind of realization of that idea as comfortably as possible. A bit cheesy slogan, but really, as a kind of high level, that's the goal, really. And as mentioned already, it's a suite of tools that kind of walk you through that journey. And kind of help and along the way, as a sort of genesis to Truffle, it's founded by someone called Tim Coulter, and back around 2015, 16, I guess, and I started playing in this space around then as well. And my goodness, the development experience was pretty terrible back then. I mean, it was so new, so you can perhaps expect it to be any other way. And Tim again was kind of early in the space and kind of started Truffle as a kind of collection of scripts just to make his development lifecycle a bit more joined up, because at that point there were tools released by the Ethereum Foundation and other folks in the ecosystem, but again it was early. So they weren't particularly elegant, or in that development lifecycle or workflow just was really cumbersome. So that was kind of the genesis of Truffle, and then it's kind of grown from there. A little more detail, as kind of alluded to, really the goal of of all the tools within this suite is to kind of give you a complete, in quotes, kind of local blockchain environment. So all the kind of core constructs that you're going to be needing to work with as part of the development. Obviously, when these go live onto public networks or other types of networks, there's constructs there such as accounts and APIs and interfaces and so on, that you need to work with. And Truffle as a suite of tools really brings all that to your desktop and allows you to build and evolve, kind of model what you're trying to do, build, iterate, etc. It's pretty popular. Aggregate, I think about 7 million downloads, and mostly open source. And it used to be all open source, and then the kind of caveat to that is Truffle Teams, which I'll show briefly, is like a hosted product, so it's not open source. We might open source bits of it over time, but everything else, particularly Ganache and Truffle CLI, all open source. So when I get to the end, I'll talk about how if you're interested in potentially contributing to it in any capacity as well. Just some of the companies that use Truffle, just some names here. You can obviously see some big names, small names, and a long tail kind of beyond that. All right, so kind of jumping in to the tools themselves. So Truffle itself, as I mentioned already, is a command line interface-based tool. Really, Truffle is about the contract development lifecycle. So I've kind of called out on this slide here some of the commands you might you typically would use. So once you've started to write the contract, I'll park unboxing for the moment because we'll be coming back to that. But once you've got a contract and you're kind of ready to compile it down to bytecode, there's a compile command. And there's other I'm kind of keeping it very, very simple right now. But just there's a compilation command that will compile it based on the Solidity compiler of your choice. We also support Viper as well, which is another language within which you can write contracts. Same with test. So when you want to write and run tests to kind of ensure that your code is of a reasonable quality, particularly as it evolves, we have a framework for that, test runner and so on. We have a debugger, and again I'll show the visual debugger later in the context of Teams because that's pretty neat. It's also visual on the CLI as well, but it's a CLI debugger, so it's a little more fiddly to kind of step through, but it's there, and it's it's once you get used to it, it's not too bad at all. Just not perhaps what you might be used to if you're used to like IDE based debuggers. And then another command is migrate. So when you're ready to once you've done a few of these things and you're ready to migrate it to another location, and typically that first that's going to be local to Ganache, and we'll get to that in a moment. we have a command or a mechanism within which you can do that. And similarly, when you're ready to migrate it to a testnet, testnets being kind of the equivalent of staging environments. Again, I don't know if that's come up in the course thus far, but you can get free ether and really designed to kind of play around, but it really simulates the mainnet, the public kind of production environment as it were. But yeah, so you can migrate using that command. And then convention wise, once you've installed Truffle, I don't really mention how to install it. Actually, I could do if needs be. It's node based, so as long as you've got Node installed locally, Node.js, you can install it by npm. So npm install -g if you want to install it globally, and then Truffle. Once that's installed, then you can just start firing off commands. So Truffle, the name of the command, and then any depending on what command you're running, there may be some parameters that you pass into that. And then typically, well, I say typically, it depends. You might use a box, and this is a kind of segue into the next slide. We also have a command here that's not listed, which is a init, which will just kind of spin up a a kind of blank project for you. But all the core directories, the Truffle config file as well, which is where you store all the configuration information about the project. The networks that you want to deploy it to, the compiler versions you want to use, and so on. So Truffle init will spin up essentially a kind of blank project for you. But that said, a good segue into Truffle boxes, because again, these are particularly good if you're kind of new to the space, just starting out. What they are, as kind of alluded to already, but to give it more detail, they're kind of boilerplate projects, really, really great from a learning standpoint, because we have a ton of them, and or for using as a kind of for kickstarting, as a kind of scaffold for a new project you might be working on. We have example ERC 20s, ERC 721s, like a CryptoKitties example. We also have a ton of front end code in there, boxes that contain front end code. So if you're building a front end to your DApp, which obviously is quite common, we have great examples for that, and using a lot of different popular front end frameworks as well. We also have 3 flavors of boxes, official ones that we as Truffle support and maintain. So if there's breaking changes in Truffle or GANACHE or whatever, we'll kind of update those boxes accordingly. We also have partner ones, wherein folks or companies that we partner with, Microsoft have some boxes, and gosh, like Chainlink and Aave and so on. Just to pick out a few random, you have partner boxes, which are typically a showcase of or a good way to get started with whatever given service that company might be put out there, or protocol and so on. And then finally, we have community ones, and it kind of overlaps with partner, but community ones are just folks out there in the ecosystem that maybe put together something and just we'll get it listed. We do typically do a quick check, sanity check, to make sure it looks all good. And then we pretty regularly release them. Lots, especially a couple of DeFi ones that we've got in there recently. And just a bunch. And then the way in which you would, if you've got Truffle installed already, you can just do Truffle unbox and then the name of the box. And I'll just quickly, just open up the link just to show you guys. You can see here, I'll just scroll down. We got tons and just big long list. It's only worth calling out. Towards the end, there's kind of a couple of new ones. Just tons, like Chainlink. So yeah, really nice way just to play around and just see, get different, sort of angles on things you might do, if you're kind of building a project in this space. Cool. So that is boxes. Moving on, to GANACHE as another tool, a very complementary tool to Truffle as well. Because when we talked about Truffle migrate earlier, so when you kind of migrate it, once you've got a contract or contracts, whether it's something you've just unboxed and you kind of want to test that out yourself, or of course, one you've written, or contracts plural, you need to deploy it somewhere so you can start testing it and kind of working with it. Now, of course, you typically aren't going to want to push that up to a test net yet, so that's where GANACHE comes in. What GANACHE is a local blockchain environment. Minimal, like zero config, so you can just start it, with GANACHE CLI as a command, and or there's a few other ways. I'm not going to touch on those in a moment. And we have GUI based version as I mentioned as well. And really it's built for development, so these other, the test nets that are out there, really more about simulating, the production Ethereum network, often referred to as mainnet, basically. And Ganache at the other end of the spectrum is when just something you'd spin up locally. But when we say built for development, it's blocks are insta-mined, so it's really, really quick. Now to there's no latency, for a block to be mined. You get a bunch of accounts spun up for free, as it were, all loaded with 100 Ether to start with. That's configurable. So if you want to change that default, you can. And of course, more than 10 accounts. So all the things that you would need, to help with that development process are just there and ready to go. A few more things along the bottom there, and you can see 2 tiny screenshots of the 2 different versions of that. A third way to spin it up, and I'll also got a screenshot of Ganache UI on the next slide as well, is actually directly from TRUFFLE CLI. So there's a command called TRUFFLE develop, which is pretty neat, because if you're in the context of a given project and you run TRUFFLE develop, it actually spins up an instance of Ganache for you behind the scenes, and then takes you into a command prompt. So you can start interacting with those contracts directly from the command prompt. And behind the scenes, as I say, it's got the Ganache instance. You would still need to migrate them. So typical flow is run TRUFFLE develop, run migrate, and migrate, by the way, compiles them first. And we'll check to see if there's anything changed and see if it needs to recompile them if there's something changed, or if they're not compiled at all. And then you can just start interacting with that contract from the CLI, this case. So again, there's conventions within which you do that. But pretty neat, so it's pretty rapid, to get started, albeit, a little bit of a learning curve because you're working in CLI here, and you need to know what commands to fire off and so on. And you can see a little bit of output here, when you run TRUFFLE develop, and you can see some of the accounts. So it spits out all the public and private keys for you. This being just pruned, trimmed off. You get 10 accounts, 0 indexed, and then the private keys listed after. So you can then start, signing transactions either through MetaMask, as Solomon mentioned earlier, or other means, and just start interacting with it. So that's I say, there's, you can start Ganache just manually, Ganache CLI command. You can do it by TRUFFLE develop, or as mentioned as well earlier, there's this UI-based version. And I would lean folks towards this, if you're brand new to this space, and you just want to really start to familiarize yourself with the constructs, as I mentioned. Ganache UI is a pretty good place to start, I think, just because it, as you can see here in this screenshot, visually exposes all the things that you need to, sort of care about. And, again, sensible defaults and all the info that you need. And behind the scenes, it's just Ganache. It's just a GUI on top of, a blockchain instance running locally on your computer. It gives you the things like the mnemonic, the accounts, the 10 accounts, you can see loaded up with ETH. Blocks, as they're mined, you can configure it such that they're, mined on a certain time interval. The default is insta-mined. Basically, when a transaction is sent to the Ganache instance, immediately it's, added to a block. Again, as mentioned on, in the real Ethereum networks, that's not the case. I think you've been digging in a little bit, perhaps in the last lecture, about that process where blocks are, mined and consensus is reached, and eventually, but it takes a little while. Same with transactions. You can see the contracts that have been deployed and events that have been emitted, and just raw logs as well. So pretty nice, if you're starting out. Once you get past a certain point, it might be a bit, and you just know a bit more in a broad, in a sort of broad sense. You may not need, you probably just find yourself a bit more efficient, for want of a better term, on the CLI and another tooling. But yeah, again, it wouldn't be like a super strong recommendation, but definitely perhaps have consider having a look. Again, if you're really new. It's also cross-platform as well, so you can, whatever OS you're using, it should be supported, which is nice too. Cool. So that's Ganache. I just want to mention another feature of Ganache, which is particularly relevant in the DeFi space, which obviously is blowing up, of course. And that's something called Ganache forking. And what it is the ability to just take a snapshot of well, just to back up momentarily, when you spin up Ganache ordinarily, like in the scenarios we just talked about, it's essentially empty. It's an empty chain. As you send transactions to that net, to that instance, that Ganache instance, blocks are added, etc. But that's it. There's nothing else there because by design. Forking, on the other hand, allows you to take a snapshot and essentially kind of fork another chain. Very often that's mainnet. And you can then interact with it as if it's your local network, so it's essentially Ganache, and you can, send transactions to it. There's a bit more latency because it's having to query query mainnet and get state from mainnet and so on. But it's really, really powerful, particularly with DeFi, because it's very common that you're composing, kind of writing contracts that interface with existing on-chain stuff. It doesn't have to be DeFi, or financial stuff, but it can be anything, any contract that's on chain that's got an interface that you can, interact with, which is pretty much all of them, unless everything's private, whatever. So yeah, it's not just DeFi, but it's, use cases for DeFi are such that you very often write things that, perhaps invoke things on, send a trade to a Uniswap or something like that. So really, really powerful feature. I won't go into too much depth on it now, but just really want to put it on your radars as a thing, as you kind of go deeper into this space. I got another, I kind of mentioned most of that, why I think, why you would do this. And really, yeah, just to kind of elaborate a little more, kind of dev production parity. So it allows you to test your contracts against, mainnet, chain code. Oh, and you can simulate, you can essentially impersonate any address as if it's you. So you can sign transactions from any address. Like I could essentially take over an address that has, 150,000 ether or something, and play with that ether, pretend I'm rich. But in a forked scenario. And one analogy I've used in the past, I don't know, for what it's worth, I don't know how great it is. If you think of Git or GitHub specifically, say, and you fork a Git repository that you only have read permissions to, you can then you've essentially got a snapshot of that repo, and you can do whatever you want with it, but you can't kind of you can't write back anything over the top of it, because the original repo that you forked from is, you don't have permissions to do that. So Ganache forking is somewhat analogous to that. You can take a snapshot of, essentially mainnet and at a given block, and that can be either the latest block or whatever block you specify. Interact with it as if you are God, and whatever, interface with any contracts. And then, but obviously you don't really, that's just a snapshot. It's not real, but it's very useful, depending on what you're building. So yeah, just heads up, that's a thing. There's a nice thing in Truffle Teams, which I'll show you, because one other thing I didn't mention as well, is you do need something called an archive node with which to do that, which is pretty huge. If you're going to kind of, I think it's many, many terabytes now, because you essentially would add a node to the network, running it in archive mode, and it's just the way in which it stores all the blocks. It stores a lot more state and so on. But you don't need to do that. There's archive nodes out there, and in Truffle Teams we have the ability to create something called a sandbox and you can optionally fork that, and I'll touch on that later. So FYI, that's and that's a particularly useful feature of Truffle Teams. Cool. Let me just, I saw some, I think maybe some questions coming through. Let me just jump in to see, make sure I haven't missed anything. Okay. So what's the difference between Truffle and Hardhat? Yeah, good question. They were essentially kind of a lot of overlap, very similar. So like I think, Hardhat has some strengths in some things, Truffle has some strengths in the other. I haven't used Hardhat a ton, so I can't be too objective. But BOM, always worth a look, just to be aware of the different tools that are out there. What use does Airbus have for Truffle? Good question too. I think I wasn't involved in the project, or I remember we might have had conversations with them directly. I think they were using it for like an audit trail for parts, going into airplanes and stuff, or whatever. Other than that, that's about it. I don't really know. A lot of companies have kind of been exploring the space, proof of concepts and so on. So how much storage does each snapshot take if you are snapshotting Ethereum mainnet? Yeah, that's a good question, Albert, as well. Not really any, because you don't, other than when you interact with a given block or essentially a given contract, you then are pulling down state to your local Ganache instance at that point, but you're not having to like synchronize the entire sort of historic state of mainnet, which, as I said earlier, is huge. So yeah, it's a very efficient way. And then particularly, if you use a sandbox, which I'll touch on briefly later, really nothing is stored on your local computer. And then, yeah, I'm seeing a few other just comments there. Yeah, cool. Yeah, fire any questions in, any more questions as we carry on. Cool. So that's kind of just briefly, again, super high level, Truffle and Ganache, as tools in that flow and that kind of workflow. So next up I want to mention is Truffle Teams, which is our newest tool. And this is more focused on the DevOps / operations. I know DevOps is is that too. For once you've kind of done some on this kind of diagram here, once you've kind of been working, kind of writing some code, building it, testing it, and you're ready to move beyond that, so you can, as you mentioned earlier, from Truffle CLI, migrate is the command to another network, and then kind of not really monitor, and these are just kind of buzzwords on this thing, to be frank, but all that sort of right hand side type things. So once something's gone live and you want to kind of say monitor it and interact with it, potentially pause it, whatever it might be. Truffle as a suite of tools, client side tools primarily, doesn't have the, historically at least, didn't have the kind of most robust story for some of these kind of downstream things as part of that kind of development life cycle. So that's where Truffle Teams comes in, and design, the kind of goal of it as a product is to, kind of aid in this side of it, this side of that kind of flow. And I'll quickly just show it. But I was originally gonna, just as a side note as well, do some stuff in Truffle CLI briefly, but because I'm on this Apple Silicon, I need to dig into it. It was literally late last night. I was like, let me just install Truffle on here. I was like, gosh. And my main machine I can't use right now. It's in a room in my house. My son's asleep in there, so it's like got 2 massive monitors and stuff. So yeah, too much information, I'm sure. But anyway, so what I would do is, what I thought I'd do instead is show Teams, and that will kind of give you a flavor of both that, which is kind of neat in and of itself, and I'll just kind of touch on some stuff as well, like boxes and whatnot, as we go through that. And this will be quite brief, but I thought it'd be nice to show you a tool that may not be that familiar with yet. So with Teams, you start by wiring up a GitHub repo for a project. So this is one you could sort of check out yourself if you wanted to. It's on Truffle Suite on our GitHub org, where Truffle. I can just show you that too briefly. I can see this is all the projects I talked about. So Truffle itself, Ganache, our public website, Drizzle, which we haven't touched on, which is like for building front end library, etc. So this repo is just an example project. It's actually a bunch of things. We used it in a webinar series we did a little while ago. So there's a bunch of branches here. As you kind of open different branches, there's quite radically different things. It started pretty simple, simple contract, and then we turned it into an NFT, but starting with using an ERC 721. And apologies if that doesn't mean anything, but basically it's a standard for a non-fungible token. We then switched it out to 1155, which is a more modern implementation of ERC 721 that's backwards compatible, and actually also supports ERC 20 as well. So it's kind of fungible and non-fungible wrapped up into one suite of contracts. It's kind of neat. And then finally got really wacky and DSN, where you can send what's called meta transactions. You can essentially allow people, you can pay for people's gas for transactions that they send. You essentially sign them on their behalf. And again, that's on step 5. So all of that's there. But the way, let's say you wanted to play around with that in the context of Teams, you just click this button here, wire up to GitHub, kind of add that repo to Teams. first thing it would do is it's something called a CI service, continuous integration service. So it would just, first, as soon as you wire it up, it would just try build that project. Just basically exactly the same as if you did truffle compile on the CLI. And it gives you all the output, essentially the same output you'd see on your, your terminal if you're doing this locally. But what it also does is run the tests. So if you have written tests, which is always good practice, of course, for a given project, I will also, do the compilation and then run the tests. And then, you can see here, like, it's the way, with continuous integration systems like Jenkins and Circle and so on. Then you can see the kind of status of that. So that's kind of feature number one. I'll just give you a brief tour. I didn't want to kind of dwell on some of these. One thing I did want to mention is these sandboxes as well. So these are Ganache instances in the cloud. And you can just, and I should stress as well that there's a paid tier to TRUFFLE teams. There's also a free tier. So all the things I'm showing you, don't, it's free. And if it's public repos, that we basically kind of got a similar model to GitHub. So you can get a free sandbox, and you can also, I haven't forked any of these, but you can fork them. So, and that's, behind the scenes using an archive node as well. So, in that scenario where you maybe want to interact with existing on-chain stuff, on mainnet, you can do it via a sandbox. So you just go new sandbox, check the forked option, you choose the network you want to fork from, any of the test nets or mainnet, and then you get an RPC URL here, and then you can start interacting with it. It's kind of neat. Basically exactly the same manner as if it was running locally on your local machine, which is kind of cool. So the other things I just wanted to briefly show is deployments as well. Again, I mentioned this in the context of TRUFFLE CLI. You can do migrate to deploy it to, when you're ready, test stuff out. You can deploy it to, the test nets. You can see a couple of examples here. This project was just playing around, by the way. So did some deployments to Rinkeby and Goerli to test nets. And there's dashboard as well, which is kind of analytics. Other things I just briefly want to show, which I think is really nice, is once you've done a deployment, you can then interact with that. And this is where it kind of overlaps a little bit with Remix, but I think it's a little nicer because it remembers, the contracts that you've deployed to, like, Goerli or, or mainnet, and all the transactions that have been sent to them. And then you can, essentially do the same thing that Remix has. So you can then actually just move the Zoom window there. So let's say I want to like award myself an NFT. Let me just go ahead and just get the, oops. So I've wired up my MetaMask instance to point at this sandbox here. Just award myself a badge. And then just sign that transaction. So it's free ETH, or it's just GANACHE ETH. So get the transaction hash there. And then now if I go back into transactions, that top transaction there, again, I'll move the Zoom windows, was the one I just sent. This, by the way, was to a sandbox. But what's kind of neat is you can go ahead and debug it and, step through. And this is really, I think, back to, coming up to the end of my session and a good segue into Solidity, which I know is the next part of today's lecture. You can actually step through the code here of this function that we just invoked. So this award badge, and you saw that I passed into arguments there, an address, which was the attendee that's, in this case, attendee, but basically a person that you're awarding the badge to. And then the way ERC 1155 works is it has this concept of a type. Again, if anyone's played with ERC 721, it doesn't. It's just inherently, that badge, that instance, that contract is that NFT, whereas 1155 is a little different. And then you can step into it. And again, this is an Open Zeppelin implementation of 1155. And you can just see all the things going on here. And you can, there's a state explorer on the right-hand side. So, as states being updated, you can see that. So yeah, really, really neat, I think, from a learning standpoint in particular, just because you can, deploy this stuff, play around with it, debug it in a very nice kind of visual way. So yeah, just kind of thought that would be useful to show that. Cool. So back to the slides, kind of nearly there. I think I showed everything I was going to show, and again, kind of glossed over bits and pieces in terms of the life cycle, but you can sort of hopefully get a little bit of a feel of how that plugs in to the broader life cycle. And then, yeah, finally, next steps specifically with Truffle itself, if you want to go deeper, firstly, get in touch anytime. I'll just put my email address there. If you've got questions, if you're getting stuck on anything, we have support, public support channels, but, by all means, reach out to me directly. I'll try to help or connect you to someone else in the team. There are sort of good links for getting started as well. So our docs are pretty decent. We're about to do a big overhaul of them. We have some pretty nice tutorials. And then, as mentioned, boxes. Probably the last one there, I think, is probably once you get past, a little bit of familiarity of what's going on and using Truffle, boxes are a great place to start because, they're just really good ways to dig in and play around, and you can obviously browse and see which one takes your fancy, sort of thing. And then finally, if anyone's interested in contributing to Truffle, it's a pretty, sort of sizable open source project or collection of projects. Reach out. I'm a huge, as the years have gone by and, being in tech my entire career, many different hats. I'm such a, advocate and, and so passionate about open source. And particularly, if you are, sort of earlier in your career or starting out, in your career soon, contributing to open source doesn't have to be Truffle, by the way. I'm not trying to sort of overdo the sales pitch here, but any open source is really, just good things to do, to contribute to. You learn about those projects, and probably more importantly, or equally importantly, at least, is that you get kind of credibility in the space. Employers, if I'm interviewing someone and they've contributed, authoring back to different projects, big thumbs up to that person. So you can put it on your resume, or just, and obviously typically shows up on your GitHub profile, and that's a big thing too, if you're in this space or any space within tech, of course. So yeah, back to the point about this, if you're interested, we do a pretty good job, I think, of maintaining all our kind of issue backlogs. So we label issues with like good first issue, which is a pretty standard convention, or there's help wanted, so either someone themselves might label it as, if they're stuck on something, and it becomes a little bit Stack Overflow-esque at that point, but you can wade in and help. But yeah, certainly good first issues is ones that we'll often label, and then it's just as it sounds, sort of opens the door to someone who perhaps hasn't contributed before, just because it's going to be relatively straightforward, and not to sort of undermine people's intelligence, but big code bases can sometimes take some getting used to. So good first issues, obviously, that just nice entry points into that, and that applies to a lot of other projects out there. So again, I'm not trying to oversell the fact you would need to do this for Truffle, but any projects, highly recommend it. Cool. So that was it. Yeah. So thank you for listening. Hope that was useful. And then I'll kind of jump over to any more questions if there are any. Otherwise, with that, I will hand back to I guess Solomon. I think Nathan, you were doing the Solidity section.
Yeah, that'll be me. How about we just take 5 minutes? You could ask Kevin any questions, or you could just take a break if this has been a bit too much. And thank you so much, Kevin, for taking your time to tell us about.
My pleasure. Yeah. Well, thank you for having me, guys. Yeah. I see a couple of questions here. Yeah, I'll stay on for a bit longer, of course. Fire any questions. And let me just throw my email address in here as well. And by the way, I don't think I shared them with you guys yet. Nathan, that's specifically Solomon and Nathan. But I'll make sure. I think you maybe do have, I guess, at least read-only access to the slides. So the slides I think will be pasted into the main deck that you guys have. So, but yeah, reach out. That's my Truffle email address. And then there was a couple of questions. Can forking create any security holes in the system? Not really. And feel free to elaborate on that if I don't kind of answer your question like properly here, but not really, because you're essentially just taking a snapshot like of another network, and you have there's no way in which you could write back over the top just in the same way, as much as I might want to update existing state on chain to say that, oh, my account actually has 500 ether or 1,000 ether, surprise, like I cannot do that just by the very nature of the blockchain by design, right? So in that sense, there's no, if that's where you're going with that kind of question, there's no kind of weakness that it introduces there, because it's, you're essentially just taking a read-only snapshot, and there's, no way you can write that back as much as you might want to. And then in terms of perhaps anything on the snapshot itself, not really, because you're just reading state that's out there publicly anyway. So no, I think is the easy answer, unless it's, perhaps really low level, obscure vulnerabilities or something that I'm just unaware of, which so hopefully that answers that. And then Albert, I think maybe that was that part, the answer to that one, I guess, in a sense, yes, since you can try attacks out on a local, but yeah, that's true. I mean, that's like you said, lowers the barrier to attacks, however, any modifications to a local, yeah, absolutely right, Albert. But at the end of the day, if something's vulnerable, it's just like the same way that, like hacking tools are just more accessible than ever, like Kali Linux or something like that, where it's just like makes it almost anyone can run that Linux flavor and just has access to a pre-configured suite of tools and can start doing damage if they so inclined, and probably get arrested. Where in this case, obviously in the case of blockchain, I guess it just maybe makes it easier to craft and explore, vulnerabilities. But to be honest, it's probably more likely, if contracts are verified on Etherscan, and most contracts are, meaningful ones. And by extension, you can see the source code. You can, like security researchers and stuff would find, or hackers, depending on their motivation, be that sort of good or bad. There's plenty of other ways in which they could find the vulnerabilities. Forking doesn't necessarily, maybe helps, would be one way in which they would do that, sort of validate things, but it's not like, it's there anyway. If it's vulnerable, it's vulnerable. So yeah, and then Albert, what are some large unsolved problems for Ethereum developers? Gosh, that's a good question. Yeah, wow, for developers specifically, I mean, I think the tooling space is definitely getting better. I think, one thing that, like, and this is something I think about a lot personally at Truffle, we think about, is like, there's that life cycle. It still could be improved. Just that, the barrier to entry, is real, I think. It takes this, is again, getting better and got better over the years. So that's, I think, just that sort of DX developer experience, could be, ever smoother. I think, decentralized storage as well, things like, IPFS and, and Filecoin, and that's maturing, rapidly. We're doing some work with them, as well. That, is a key part, I think, of any sort of, not any decentralized app, but, like some. And that's something that's like the developer experience there, and the joined upness, for want of a better way of saying it, between perhaps writing your smart, your contracts, and then the actual underlying assets, and deploying those decentrally. It's different worlds ish, different tools to some degree. And again, there's some degree of unification coming there. Gosh, and yeah, and I think another one is like, making sure things are secure. I mean, we touched on that a little bit in that response to the forking question. But obviously security is hard, and making sure, and I think perhaps there's not both an awareness side of things around that, like the fact that you need to get things secure as you possibly can up front, is perhaps that not as well understood as it should be, because it could be too late, right? If a vulnerability is discovered in your contracts, before you know it, assets might have been drained, be that Ether or other things, right? Things may have been taken, accounts may have been taken over. So I think that's a hard problem to solve. So how do you, and different programming, some, like I think Viper is a bit, again, I'm not that experienced with Viper, is a bit more, some of the other languages are more designed to be a bit less expressive and more constrained, but they, less expressive than Solidity, for example, but by design, and, less easy to make, mistakes, I guess, vulnerabilities within them. So that's another thing that needs some work, I would say too. And then ETH 2.0 as well. That's a big thing. Obviously, that's the beacon chain's live, but you can't deploy contracts to that yet. That's imminent. I think side chains as well. I don't know if you guys are familiar with that, or that's come up in the course. Perhaps not yet come up in the course, given it's only week 2. But layer 2 solutions. And some of these other ones, reducing gas costs, that's a problem, just economic problem because everything's so expensive. Side chains help solve that, because gas is way way less. And then roll-ups, same. Is there any development for something like an automatic audit? So one, like MythX is worth a look as a service. It used to be called Mithril. Just pull it up, MythX.io. So I think it might be a fully paid service now. They used to, it might, by all means double check yourselves, but they do like vulnerability scanning of contracts. So all the kind of major known vulnerabilities and obscure ones too, will scan for. Of course, they have to be known. So that's the thing, but that helps, right? Because especially if you're starting out, that might be something you don't know what you don't know, and there's some of these vulnerabilities are pretty obscure. 2 things on that note as well. Vulnerable DeFi. I came across this recently. It's one of the guys behind Open Zeppelin did this. This is kind of worth a look. So this is just some challenge it. This is some example DeFi contracts that have like known vulnerabilities within them, and you have to try and hack them. And then I think they have the answers as well in there, but you obviously don't look at those first unless you just want to peek. That's worth a look. And then what's the other one? There's another equivalent one just for general vulnerabilities, not DeFi specific vulnerabilities. But that's something to kind of check out if you want to kind of start. Just again, it starts with obviously kind of knowing, just getting sort of more deeply familiar with Solidity and other languages, programming languages to write contracts, and then just understanding the types of vulnerabilities that are out there, and then even then it's, I didn't mention this, but perhaps in the context of like the developer things aren't solved yet, is just baking in audits and or like bug bounties and or things up front as part of that development life cycle. And that's not as perhaps inherently well understood, just because people are so used to like pumping out web apps or mobile apps, and you can update them on the fly, and again, it's not that security care about it, but you can kind of patch things, and even then obviously vulnerability things leak out. But with this, with this space, there's a lot more at stake. Real money, massive sums of money can be lost immediately, not just perhaps the database compromised, which is bad too, but so different types of vulnerabilities and different things at stake. So anyway, I could go on, but that's a little bit of a brain dump of different things kind of on my radar. Cool. Some of these. All right. And I guess final thing, just to kind of reemphasize it, feel free to reach out. Any questions on Truffle or the space, and or you're interested in contributing or anything else, my email address I think was in the chat. So with that, I'll hand back to Nathan. And thanks for having me, guys.
Thank you for taking your time to present to us. So right now, I guess we'll move on to our next section, where we'll be talking about Solidity syntax, and I'll give you an introduction to that language. So then Solidity, it's actually very similar to JavaScript, if you guys are familiar with it. So next slide. Let's first talk about some data types in Solidity. The first data type, it's pretty basic, Boolean. If you guys have taken 61A, 61B, it's pretty similar to what we've had. You can still use the not logical negation the two and signs is and, you have or, equality, and inequality. There's only two values, true or false. Pretty self-explanatory. Integers is also pretty self-explanatory. You could do comparisons, bit operators, shifts, and also arithmetic. What's unique about solidity is that there's different types of integers that vary based on how large the integer is. For example, there's uint 8 and uint 256, which covers unsigned integers, which are just positive, while integer and int 256 covers both positive and negative integers. Uint 8 covers all integers from 0 all the way to 2 to the power of 8, while int 8 uses 2's complement to cover all integers from 2 to the power of 7 to negative 2 to the power of 7. Does anyone know what 2's complement is? Yeah, you could type in chat. So I take it that everyone knows what 2's complement. Okay, yeah, just making sure. So it's just another binary representation that we could use to represent integers. Yeah, so then you do bit operations and shifts. So what a shift is you are pretty much converting the integer to binary form, and then you're just moving it left or moving it right. And that's equivalent to multiplying it or dividing it by 2 to the power of y, which is how many places you're shifting the integer. Yeah, this is similar to what you learn in 61C. And also there's bits operations where you could negate bits. And then int 256, because we're doing 2's complements, 0 is actually -1. If you don't know how that works, that's not too big of a deal. Just search up 2's complements and binary representation of numbers. Next slide. Then there's also addition, subtraction, multiplication, and division. The cool thing about multiplication and division is that they're all integers, so there's no decimals involved. If you divide a negative number by a positive number, it'll return the ceiling of the number. For example, -5 divided by 2 is not -2.5, but it's -2. 5 divided by 2 will not be 2.5, but it'll be 2. And also addition and subtraction. There is overflow such that -1 is equivalent to 2 to the power of 256 minus 1, because as an unsigned integer, there are no negative numbers. So now let's talk about addresses. Addresses are similar to integers, but they only hold 20 bytes, which is the size of an Ethereum address. An address payable is a type of address, but then you can send money to an address payable. Like you can't do that to a regular address. You could do comparison operators on addresses. And for an address payable, you could call two functions, transfer and send, which is to send money. Let's go over the transfer functions. So then the transfer function fails if the balance of the current contract is not large enough or the Ether transfer is rejected by the receiving account. So what happens is that if the transfer function fails, then the entire contract would stop executing. It's the more secure of the two transfer functions. And there's also send, which is similar to transfer, but then the only difference is that when the execution fails, send would just return false and the current contract would continue. So you could use that if you're trying to control for whether the function fails or not. Here is an example of how you'd call transfer or send. So then let's talk about typing.
Sorry, is payable a keyword if you go back?
Yeah.
Okay.
Yeah, payable is a keyword because address payable is an address that we could transfer or send money to. Because you can't do x.transfer on my address if it doesn't have a payable. Yeah, does that?
So it's only used when you declare addresses?
Yeah. Michael asked, when is send being used? Send is not being used because we're doing transfer and then they do this same function. But then this will also work if we replaced x.send 10. Yeah. So now let's talk about the typings of contracts. So contracts do not support any operators. And then they're kind of similar to classes in that you could, when you declare a contract D, then all instances of the contract will be of type D. For example, we could declare a new D type in D new D. And then also contracts could, send is more dangerous. Actually, send is more dangerous because it doesn't stop the function altogether. So then if there is something dangerous, then you have to account for what happens when the function returns false. So yeah, because transfer would just stop the function altogether. Let's go back. So then if D extends another function, let's say D extends contract B, then we could also cast new D to B because D extends B. You could use type, which is a function that could return the type information of a contract. And then the members of the contract types are the external functions of the contract. So pretty much any public or external variable or function you could call outside the contract. So for example, create D, you could call create D outside contract C. And you could also do that if it was a external. Now let's talk about strings. So string literals are a value type. It's pretty similar in Python, Java. Here are some special characters. And unlike Java, you could compare them using the double equals. They're stored in bytes. So then you could do bytes 32a equals string literal, and that would work. Yeah, so now let's talk about enums. So enums, they denote a special type of variable. So you could enumerate something like action choices, and any action choice could only have 4 possible values. So that's really good if you're trying to control for errors, because you could only assign any variable defined under the enumeration as the values defined over here. The integer type used will be large enough just to hold the values. So then here are some precedence rules. So this just goes over which operators will be executed first. You don't have to memorize it, but then it's just good to know when you're actually writing smart contracts. Now let's talk about data structures. So then there are arrays. You could have a static array where you define the size predeterminately. You can also have dynamic arrays where you don't define the size. If you add anything to an array, then that would return a new length of the array. Here's how you get the length of an array. And you can also set the length of an array for dynamic arrays. You can't do that for static arrays. And you can also have multidimensional arrays. So the functionality of arrays is pretty similar in Python, Java, and Solidity. And we also have structures. This just allows us to group up our values. So in a bank, for each account, we could have an owner and a balance. And that's just good for organizing stuff. And mappings are basically dictionaries in Python or hash maps in Java. You have a key value pair. This is the first the first one is the key, the second one is the value. So then if you type in a string, then you could assign a value to it. That just helps you find things quickly. And yeah, so that's how you return a value, by calling it by key. You could also call it like an array too, and you put in the key. And then you could also delete pairings. And then if you delete the entire mapping, then you set all elements to 0. And you can also nest the mappings too. So now let's talk about functions. Yeah, so then here is the anatomy of a function. There are mainly 4 types of functions. Public is just all you can access. Externals are like public, but you can't call them inside the function. The reason why you use them over public functions is that they actually cost less gas in Ethereum, because when you're running a smart contract, you're running it on the Ethereum virtual machine. And the more complicated it is, the more money it's going to cost you. So externals are more efficient that way. Internal contracts, you can only call them within the contract, as well as anything that derives access from it. And private, you can only call it within the contract. As a general rule of thumb, you want to use the one closest with the smallest, with the most privacy you need, so that you could save as much money as possible, because the more complicated a function is, the more money it's going to cost you on the Ethereum virtual machine. Here is just how you define a function. And you could also set a return variable name. Only functions marked as payable can receive Ether. So here is the deposit function. It's payable, so then other users could call it so that they could receive money, because what happens is that it increments the balance of the sender. And then a fallback function is a special function which has no name and is invoked when the function is called, and it doesn't match anything else that you've declared. It's external because other users could call it. So for example, here is an example of a fallback function. If you don't have a default fallback function and you receive Ether, then I don't think you'd receive the Ether if there's no default function. And then the Ether just goes to void, I'm pretty sure. And a constructor just loads all the variables. There's only one that's allowed. So then it's not like Python or Java where you could override it and have multiple constructors. And there are 2 types of implementations. You could either call it a function and then give the contract name and then the arguments, or you could just call the word constructor, which is reserved. So here is a constructor. Are they any different? It's just 2 ways of calling the same thing. I don't think they're different. Yeah, so then, does anyone have any questions? So if anyone has any questions, then I could answer them. Otherwise, I'm going to demonstrate the homework for this week. Yeah, let me demonstrate the homework then. So what you do is you're going to deploy a smart contract, and then you're going to be sending yourself Ethereum. We're not going to use actual money, but we're going to use a test network. You should use the Ropstein test network. So here is the function. Let's deploy it. So first we need to compile it. And then we deploy it on Bank. And then I'm going to send it to myself first. So how I do that is I load my address right under. And then what I do is I just deposit money. Oh, yeah. Deposit. And then you wait a bit, it'll take a bit. And then, yeah. Yeah, the testnet is Rothstein. How does the transaction that you're enacting through the contract get verified? We have a deposit function that requires that the balance is greater than or equal to the message, equal to the balance. So then these two functions should verify that this is a valid request. I'm sending myself 0 ETH, so then it should be valid. The testnet's Ropsten. Yeah. So does anyone have any questions about the homework? How do testnets verify transactions? Do they have miners too? I'm not actually, I'm not too sure how they, yeah, thanks, Albert. Yeah, it should depend on the testnet.
It's kind of like a developers are, there are miners, and miners are developers are usually mining on the testnet, mainly because they're kind of selfish in that they need to use the testnet to test their contracts, but more importantly, like it just ends up like trickling out to the public as well.
Yeah, thanks. Yeah, thanks, Albert, and thanks, Solomon. Yeah, so that'll be about it for the lecture. Yeah, thank you everyone for coming. Solomon, do you have anything to add?
Yeah, so
yeah.
Oh, sorry, let me share my video, my bad. So I know some people were asking about doing question 4. So I'm gonna stick around and do that for you guys, if anyone's interested. So this is question 4 from homework 1. And we can just kind of go through it together. So if you've already completed it or you know what you're doing, then feel free to hop off and do check Piazza regularly. The lecture recording should be up soon, and homework 2 is already out. It should be pretty brief, but it's there. Can we turn it in tonight, as in turning in homework 1 or homework 2? Homework 1? Yeah, so since we got it out late, like the submission form, we are extending the homework 1 deadline to tomorrow night at 11:59 p.m. So just make sure to get it out by then. Yeah, so the slides for lecture 1 are already out on Piazza under Resources Central post. They will be available for future lectures as well, and they'll be available for Kevin's slides will be available as well. Cool. Any other logistical questions? If not, we can go through question 4.
I have a question.
Yeah.
I think I asked you guys this last week about reapplying to the fundamentals decal, and then like whether or not I just get automatically admitted because I got it this semester, and I could defer like.
Oh man, I'm so sorry. I totally forgot about that. Can you make a private Piazza post, please?
Sure. Okay. Thanks.
Sorry about that.
It's fine. No worries.
Cool. All right. Yeah. Yeah. If you guys are good to go with homework 1, then have a great long weekend. If not, I'll wait like a minute for people to check out, and then I'll go through question 4 of homework 1. All right. Okay. Let's do question 4 then. So basically, how does this proof of we'll talk about like how does proof of work as a protocol work? So how proof of work works is that there are a bunch of validated transactions, and they're sent out to miners to basically mine. And what does it mean to mine? These miners will simply by proving that they've done like some unnecessary work per se, but like not useful work, which is just repeatedly hashing a given block with like a string of random bytes appended to it, known as a nonce. They can prove that if that hash that they include in the block is less than the difficulty bound, which is usually specified by the network, they can basically prove that this transaction is validated. So intuitively, it's kind of the idea that like I put in this much amount of work and expended computational power to validate and verify this transaction after like checking that all the signatures are in line and that the transaction is valid itself. So this question is asking like how do we like actually perform this this proof of work protocol using whatever like code we've created already. So does anyone have any questions about like the proof of work protocol? I think like having that context is really important for actually being able to do this problem. Okay, so I'll just keep going. Please do like drop in the chat if you have any questions. But so if we like have a we're writing our code here, and the problem we have to solve is given a previous block and a difficulty metric, find a nonce that results in a lower hash value. So in general, like we're going to be doing some sort of iterative sequence, and we're given the difficulty bound, and we need to determine that we have to determine like a nonce such that when hashing the block with the given nonce, the block includes the given nonce, we will be able to get a hash that is less than the difficulty bound. So in reality, it's just like it's really random because hashing is a random function. You're not like, it's not linear, or it doesn't have any like relationship between input points. So you're really just like blindly throwing darts at a dartboard and hoping that one of them sticks. So we're gonna just first have like a loop. So we're gonna have a stopping condition. So our stopping condition is that int of new block, dot hash, and we're going. This is a hexadecimal representation, so it will be that's why we include the optional parameter 16 to claim that new block.hash is represented in base 16, and we're going to check while it's our stopping condition is if it's less than or equal to difficulty bound, which is what we specified using generate difficulty bound. So what are we going to do? We're going to perform iterations while it's greater, while this condition hasn't been met. So we're going to say while int new block.hash 16 is greater than difficulty bound. Now what do we have to do? We have to generate a new nonce that we're going to include in our block that in our new block that we're creating. We're going to increment the number of hashes we've tried and check if our stopping condition has been met, which is int new block.hash comma 16 is less than or equal to difficulty bound. So we're going to generate a nonce. We're just going to say like nonce equals generate nonce, and the length is already passed in as input, so we're going to just say nonce length. So we have our nonce that we're generating each iteration, and we're just going to generate a new block, and we're going to set that to be a new block, and new block is going to take in an index, so we're just going to pass in the previously defined new block. We're going to pass its index, its timestamp, the data, previous hash, and our nonce. Let me make sure I don't have any typos. Cool. And then now we're just going to increment hashes tried. So what is this saying? We're checking while our hash does not satisfy the difficulty bound, which is the basically like the solution to the proof of work puzzle. The hash must be less than or equal to the difficulty bound. We're generating a new nonce randomly using this helper function. We're going to create a new block with that nonce, which will thus affect the hash of the new block. And we're going to increment the number of hashes. So let's just run it, and it should pass. Here we go. I remember in the last lecture, we need to use case gas, if not minor. Yeah, so the actual transaction doesn't matter. With each Ethereum transaction, you have to pass in basically like your gas limit and then your specified gas price, which is the like price you're willing to pay per unit of gas, and then gas limit is like the amount of gas you're willing to the amount of gas you're actually like willing to spend for this transaction to go through. So if it's like send zero or a really simple transaction, usually your gas, like the amount of gas you have to specify or pay isn't as much, but you do like, even if it's a dummy transaction, for the case of the demo, of course, like on the test net, it's like zero, like you're paying like zero, like real ether, or like zero, like real dollars in gas. It's all like fake money, or fake ETH. So in the case of a mainnet transaction, you would still have to pay. And miners will always be compensated. If they're not compensated, they just won't like mine your transaction or like include it in the block. So you'll just get stuck. Your transaction will just get stuck in like the I guess like unexecuted transaction pool. Yeah, so basically think of the test net as kind of like a simulator. Miners aren't getting paid because like they have intrinsic motivation to be mining for you since they need the test net to be developing their whatever smart contracts that they're trying to do. All right, cool. Any questions about question 4? Yeah, so proof of work is it's called proof of work because the kind of idea is miners are basically expending some sort of resource for in order for the transaction to be validated, because it's kind of like a sacrifice these miners have to make in order for the system to work. Like there has to be a motivation both ways, right? So in like exchange for the work that the miner is doing, the work being like repeatedly computing a hash, they are receiving a block reward plus their transaction fee, and that's their kind of motivation for actually mining on the network. But if the miner isn't sacrificing anything and they're gaining their block reward plus transaction fee, like what would stop them from like just including every transaction instantly on the network? Nothing would, right? Because of course they're going to try to maximize their own gain. So the reason it's called proof of work is because the miners are proving that they've done work by solving this. It's called the partial pre-image hash puzzle. And since they're proving that they're able to do this, or like proving that they've done this for each block, they are able to validate the transactions and include it in a block, and then add the block to the blockchain.
So just to continue on that,
yeah,
question is kind of like, so for example, if something is invalid, that means one of the fields are changed by a bit, and then therefore